China is spending $137 billion on a single machine. When it's finished, this facility will produce enough electricity in a single year to power every home in Germany twice. To understand the scale of 60 gigawatts, look at the Three Gorges Dam. It is considered the gold standard of hydropower engineering. This new project will generate nearly 3 times that amount of power. The fuel for this massive output begins 16,400 feet up on the Tibetan Plateau. Here, a river called the Yarlung Zangpo starts a quiet 1,000-mile journey eastward across a wide, ancient landscape. This map shows the geography breaking. Near Namcha Barwa, the terrain forces a sharp U-turn. The river hooks around and falls, dropping 6,560 feet over 31 miles. That equals sending a river over a cliff the height of 6 stacked Empire State Buildings. The water moves with such extreme violence that no major expedition has ever navigated the full length safely. Where explorers see an impassable hazard, engineers see an unbelievable density of stored, harvestable energy. Every liter of water falling through that canyon is a tiny battery discharging. Capturing that energy requires a completely different approach. You cannot build a massive, curved concrete barrier in a canyon this steep, holding a river running this fast. The rock is too unstable and the water is too violent. This diagram illustrates the alternative design. The Motuo project uses a cascade system. Engineers are building 5 separate power stations arranged down the mountain like steps on a staircase. They bypass the most treacherous sections of the canyon entirely. The water is diverted away from the main riverbed and channeled through 4 12.4-mile-long tunnels bored straight through the solid Himalayan rock, capturing energy in stages before releasing the water downstream. Getting equipment to this site presented its own staggering logistical challenge. Until a dozen years ago, there was zero road access to this area. If you wanted to get there, you hiked or you flew. Before drilling a single tunnel, an entire infrastructure network had to be blasted through the ridgelines. Highways, bridges, and entirely new worker cities were constructed from scratch just to allow the heavy machinery to arrive. To manage all of this, Beijing created a dedicated state-owned organization from the ground up, giving it exclusive funding and a single job. Taming this canyon is a supreme national priority. But this map highlights the terrifying reality of the location. This megaproject sits directly on the boundary where the Indian and Eurasian tectonic plates collide, grinding together at a rate of 2 inches a year. This is one of the most seismically active zones on Earth. In 1950, an 8.6 magnitude earthquake struck this exact area. The shaking triggered landslides so massive they blocked the river, creating temporary dams of rock that eventually collapsed and sent flood waves racing through the canyon. You can build emergency release systems, but you cannot stop tectonic plates from moving. The mountain will inevitably shake again. And because this complex sits just 18.6 miles from the Indian border, downstream communities would have only minutes to react to a structural failure. Once the Yarlung Zangpo crosses that border, it becomes the Brahmaputra, flowing directly into India and Bangladesh. It acts as the agricultural lifeline for some of the most productive farmlands in South Asia. More than 130 million people rely on the water from this single basin. That massive human stake has prompted direct diplomatic protests and deep security concerns from Indian officials. The concern in New Delhi is simple geography. Whoever controls the flow upstream holds significant quiet leverage downstream. They can restrict water during dry seasons or release large volumes suddenly during flood season. This creates intense regional pressure without firing a single weapon. The dam establishes an invisible geographical lever over a nuclear-armed neighbor, and there is no binding international treaty requiring real-time water data to be shared. As this map shows, the 60 gigawatts of power generated here isn't staying in Tibet. It is being transported along ultra-high voltage transmission lines straight to China's coastal manufacturing megacities. While solar and wind are growing rapidly, they fluctuate with the weather. Advanced industrial grids require firm power, electricity that flows flawlessly and reliably 24 hours a day, regardless of the conditions outside. The true consumers of this firm power are incredibly energy-hungry artificial intelligence data centers and advanced semiconductor fabrication plants. Right now, sweeping U.S. export controls are actively attempting to slow down China's tech sector, aiming to keep them generations behind in microchip production. In response, Beijing is forced to build these advanced chips entirely domestically, regardless of the cost. But a massive domestic chip industry means nothing if the electrical grid cannot support its huge, uninterrupted power demands. You need a rock-solid foundation of energy first. The dam in the Himalayas and the chip factories on the Pacific coast are two parts of the same strategy. This cascade system is the foundational battery required to keep those factories running at full scale, fueling China's position in the 21st century tech race. The Mo2O facility is a $137 billion machine built on an active fault line. It secures upstream control over 130 million people, while delivering the relentless electricity needed to power an empire's technological dominance.